The junk box beckons.
Hi folks, and welcome to another episode of The Art of Engineering. In today's episode, we are going to look at organic homebrewing. No, it's not what you think. My process of homebrewing is organic because quite often, rather than going with a proven design, I take parts of other proven designs and I try and marry them together. This is not done with a huge amount of technical knowledge. Sometimes I get away with it. Sometimes it's a complete disaster. Usually I can muddle my way through. It's a lot of fun because I get to look at other people's designs and take the parts of those designs that I think are interesting. And along the way, I do learn a little bit about how each design functions via my mucking around with it. Today I'm going to try and create the transmitting section of what will ultimately be a SOTA rig. The idea is that it will be a channelized rig, so rather than having a free-running DDS VFO or VXO, what is going to happen is I'll be able to select a number of channels, and that will be for transmit and receive. I may install other bits and pieces in it. I basically want to have a box I can take with me to do an activation for SOTA or POTA. And this, folks, is the 10 megahertz default signal that's programmed into what I'm going to be using as a signal source for this transceiver. It's called the PROGROCK from QRP Labs. It's an amazing piece of kit, which I'm going to show you right now. And let me show you this dastardly device. It is about the size of an HC6 crystal case. In fact, Hans Summers, and I'll put the video below that Hans Summers does on this on YouTube, fits this into an HC6 crystal case. So in that guise, it's kind of like a very expensive 10 megahertz crystal, but it is way more than that. This is like one of those steak knife commercials. This thing has the SI5351A clock chip in it, so we're all familiar with that, or some of us will be familiar with that with DDS VFOs if we build kits and whatnot. So you've got the three clock outputs. It's got TXO, it's GPS discipline, all that sort of stuff. Or GPS disciplining is an option on the thing, but it comes with the TXO. It's got a frequency range of 200 kilohertz to 200 megahertz. So you literally can configure this as a crystal for any of those frequencies and not just one of those frequencies. You've got 3 banks of frequencies with 8 possible frequencies in each bank, giving you a total of 24 frequencies that you can program into this thing. And you actually select the frequency via 3 switches. Because you've got 3 switches, it's actually a binary configuration. So you flick your switches like you're looking at binary numbers. So all those digital electronics people will love that. I'm going with the amplifier design that I used in my Mooncake transmitter. Now it used 2 BD139 transistors, which I do have a few of, but I have a bag of transistors that I erroneously purchased when I wanted to fix my Rockmite 40. And the Rockmite 40 finals went, so I thought I was buying 4 or 5 transistors, but as it turns out, I ended up with this bag. So I figure that I can afford to like blow a few of these up to test to see whether I can use them. I know that you can get up to 3.5 or 4 watts out of one of these transistors on the Rockmite. So the plan is to run with this transistor. Do I know whether this transistor is going to do the right thing? I don't know. It's an NEC D882. I'm going to bias it and use the same impedance transformers and whatnot on it, the same toroid type transformers, same coupling capacitors, etc., and cross my fingers that it doesn't explode and catch on fire. Now, here's the circuit as it stands. We have our PROGROCK over here. At the moment, it's just a 10 megahertz crystal. I haven't even bothered changing the frequency using the PuTTY terminal yet. But you can get 3 banks of 8 frequencies into this thing, and that's going to be the channelized part of this rig. At the moment, I'm just using it to generate the 10 megs. We have a 5-volt 3-pin regulator here. The 3-pin regulator is the LM7805. Now that's just to provide 5 volts to the PROGROCK. The rest of the circuit is running on the 12 volts DC. The reason why I'm providing the PROGROCK with the 5 volts is because it can handle up to 12 volts, I've been told. So maybe through 13.8 would be okay. But Hans Summers does talk about heat dissipation and whatnot in this device if you're running it at 12 volts at the maximum. So we've decided to err on the side of caution. It's a lot cheaper to buy myself an LM308 for $3 or $4 rather than blowing up a $40 piece of equipment. And over here, when I first tried to run this into my amplifier circuit using that NEC transistor I just previously talked about, the D882, the PROGROCK does not generate nearly enough signal, which is what I assumed would be the case. So I went and had a look at Peter Parker's site and his Bush 40, I think, and I just got like a driver, which is, I think this is a BC547, and randomly picked values that were close to the ones that he was using. So biasing is important, and you do need to get it right, but you get lucky sometimes. So I took the signal from my PROGROCK, fed it into here, and now I'm getting a signal out. It is rough as guts. I've had a look at it on the actual scope, and it is messy as all get out. And I will show you that on the scope just to show you what it looks like. And I'll do a quick demo. I'll turn on my TS520 Kenwood. You'll be able to hear that in the background, just to hear that the thing is transmitting, and I'll also show you how much power I'm getting out of it. But we are going to need to clean up. As luck would have it in organic building, the preset frequency, the only frequency that's set in the PROGROCK, is 10 megahertz. And I could get to 10 megahertz in other ways. I've got AirSpy Discovery and whatnot, but the TS520 has a WWV selection on it, and that's to calibrate a frequency, but that's on 10 megahertz. So we can use that to listen to the output from this transmitter that I'm building. And just so you can see why this thing is going to need a low pass filter, take a look at this. It's hardly a sine wave. So as always, I have used a little bit of Peter Parker stuff for low pass filter values and parts of the driver circuit for the PA in this design. So I will put a link below to his channel. And also, the usual thing with me, I scoot around to see what I can find, what's interesting. And this is a great resource as well. Dave Richards, AA7EE. He's got here a 2-transistor transmitter powered from 9 volts. And what I used from this circuit was, it's basically a derivative of the Pixie circuit. But this keying circuit here, I use this as the driver, and I'm keying via this circuit. So that's basically the circuit that I've used to key this design. But instead of using a 2N222A, I've used a BC547. Once again, sometimes you'll say, oh, what happens if the transistor doesn't work or it won't do the job? Well, it might be a more expensive way to find out, but if it's not an expensive transistor and you enjoy having a bit of a gamble on it, why not give it a crack? It'll keep you in the flow of the creative process, and if it blows up, you'll know that it doesn't work in that circuit.
Well, as Bill Lemura would say in the Soul to Smoke podcast, what a great podcast that is. If you get a chance, look it up on YouTube and listen to the actual podcast as well. Fantastic stuff. This is the rig as it stands. PROGROCK's providing the crystal frequency. Eventually that will be channelized, and we'll be able to use that also to build a receiver, hopefully. That's the plan. We have a voltage regulator to run that, like I said. And this is our driver transistor now, which is the same transistor as this one here, the NEC D882, because I've got a million of them. It was running hot, so we put a heat sink on it. We knew it was running hot because we put our finger on it and we went, ouch, it's too hot. The waveform was atrocious. So what I've done is I've built a low pass filter. This design came off one of Peter Parker's rigs. I'll put a link to his channel. Fantastic resource for home brewers, as I've always said. And I've used the RF chokes at the low sort of wattage we're looking at this stage in the transmitter. It's not an issue. And then that's cleaning up the waveform a little bit so that it can be passed onto our PA stage, at which stage, when I checked the output of the rig, it was a mess, an absolute mess. And one of the reasons why was because the actual coils that were being used in the final low pass filter, these ones here that came off that Rockmite kit, were were causing all sorts of issues. You wouldn't think Toroids would cause waveform issues, but they certainly were. So that was causing issues. We've now built a low pass filter based on the designs from the QRP Club, which is what Hans Summers actually uses in a lot of his low pass kits for his builds and his kits that he supplies. So we know the design is good now. You'll see there's a hodgepodge of ceramic capacitors and other types of capacitors. I would not recommend doing that. And I would not recommend ceramic capacitors for this use. We're probably losing a lot of power, efficiency, blah, blah, blah. But I just wanted to have a noodle, as Bill Mira on the Solder Smoke podcast would say. And I'm having a great old noodle here. The main thing, of course, is that we get some power to the antenna and that it's clean. So let's have a look at the waveform we're getting now. And also, let's have a look at the spectrum analyzer and see whether I can put this thing on the air or not. Okay, let's get a gander at the waveform. Turbines to speed, power on, and key down. So that's your carrier. Let's just wind that back a bit so we can have a look at the actual waveform. Oh, the other way. And as you can see there, it's obviously not a perfect sine wave, but it's not bouncing around like it was before. So we put in some supply decoupling. Like I said, we played with the filter, but the proof of the pudding will be in the spectral purity. Now, I'm going to jump over on our tiny spectrum analyzer, and I'm going to show you what the harmonics are looking like. As it appears, spoiler alert, I think we've only got one harmonic, which is the 14 meg one. That's noticeable, and it is just acceptable. I think it's it needs to be about 44 odd dB down. So let's have a look. Okay, folks, let's key down and just have a look at what this is doing. And as you can see there, once it settles down, we've got a difference of about 44.5 dB. So it just sneaks through. And this is my favorite go-to, the VK5 Amateur Radio Experimental Group public QESDR receiver at Tarlee, over 1,000 kilometers away. My watt and a half. Have a listen to this. JGBR. Thank you for sticking around right to the end of the video. My Christmas present today was spending the last couple of days working on that homebrew rig over there at the bench and getting it to actually work on the air. Now I would like to say a huge thank you to both VK2 DLF, George, who made an attempt at working me. I think I emailed you to let you know. I don't think he got my call sign, but he gave it a red hot try. And also VK2 GBR Phil, who I've worked on a number of occasions.
He sent me a lovely Christmas greeting, worked with me, gave me a signal report. Couldn't really hear me properly, but we did exchange call signs. So in my books, that's a QSO. And I was just happy to be seeing that rig on the air and have it work. And this is one reason, well, this is another reason. I've got so many reasons why I say CW is a great mode to operate in. Because down the bottom of the band, you find the gentle, the welcoming folk. They're polite. They always say GA, GE, good afternoon, good evening, 7-3, best wishes, etc., etc. And they genuinely mean it. So if you want to enjoy the hobby even more, come down the bottom of the band and give CW a crack. You will not regret it. It also gives the opportunity to build your own gear and have people encouraging you to play with that equipment. You can play radios. So thank you for sticking around right to the end of the video. Merry Christmas, Happy New Year, and I will see you in the next episode of The Art of Engineering. Oh, and 7-3 to both George and Phil. Thank you so much from the bottom of my heart.